Hey, Miss Sparks.
Hey there, I had it on mute because I was over here returning an email. How are you?
Doing good. How are you?
Good.
Okay. I need to go get my things. I was eating lunch, so I didn't see that you started math lab.
Oh, okay.
Okay.
Okay. I have it pulled up to 5.2, but if you have a specific question on one of the other lessons, that's fine. I just defaulted to this because this was the first lesson where we haven't really gone over it in class. So I just basically defaulted to that one.
Yeah, that's fine.
Okay.
I'm just kind of struggling with the entire concept right now of everything.
Yes.
Like nothing too specific, just everything.
I understand. Well, I remember when I was first learning to graph, and honestly, still every now and then, it's one of those things where it takes more of my focus than just working equations.
Right.
Graphing does. I just really have to just slow down and really take my time when looking at it. But basically, on a rational function. You'll see that 5.2 and 5.3 cover rational functions. And the reason for that is they want to start very, very simple, which they do in 5.2. And we talked about a rational function very, very, very briefly when we did parent functions back before break. And the one that we used was I think on our notes, it was actually referenced even, I think it was called the inverse function. But they are one and the same. That rational, the very simplest rational function, as you can see there on that key concept, the parent function, and that's basically what it looks like as a parent function.
Okay.
And obviously x can't equal 0, and that's why the asymptote, and that's why that asymptote, basically what asymptote means is it's a curve is going to come very, 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 very close, but never touch it. That's the definition of an asymptote, really.
That makes sense.
And and when we get into the more complicated rational functions, what's going to happen is those asymptotes are going to kind of move around the graph. And even in the most complicated ones, sometimes you'll have 3 lines. But I am not going to prohibit you from using your graphing calculator when it comes to the more complicated ones. These are pretty simple and they're pretty easy to draw because you're just basically moving a little bit to the left or the right or up or down and that kind of thing. So those simple ones aren't too awful bad. Once again, I mean, for me, Miss Stone feels a little differently, but for me, I love Desmos and the graphing calculators. Probably Desmos a little bit more just because it's kind of nice to be able to keep that parent function in that first line and then look and actually watch that transformation or the transition take place. For me, it gives a little bit clearer of a picture. And that it helped me in my learning curve when I was able to do that. Obviously, the other thing that you can do is make a table, which I think both of the videos did a good job of demonstrating how to do that. They're not as much fun, obviously. A lot of math involved in those, but that's kind of the essence of this. And then the asymptote, the thing that it is obviously it's where the curve is not ever going to touch it. So basically what that means is any place where it would be undefined. So like in the parent function that's in the key concept there on the screen, Obviously, x can never be 0 because we can't divide by 0. So that's why the vertical asymptote is going to be x equals 0. And the horizontal asymptote in this parent function is going to be 0 because there's never ever going to be a place where it's going to be 0 because you've got 1 over x. Does that make sense? And in order for this to be 0, it would have to be 0 over x.
Okay. I kind of understand.
Okay. All right. Well, doing a few examples, I think, will help with that.
Yes. Because I've watched all the videos that we've been assigned.
Mm-hmm.
But as far as the homework goes, I've gotten like on the weekend homework, I didn't even finish the first problem. I was working on it for like 15 minutes and I didn't get anywhere.
Okay. All right. Well, let me pull up over here. I'm going to pull up on my other computer what the exact assignment was and be able to pull that up so that I can work with you on it. The weekend homework was 5.2, and there were a sundry different problems.
Yes.
All over the place, right?
Yes, on page 313.
Yes. All right, so let me pull all of that up. Fun stuff.
Fun stuff.
I hate to hear that you spent 15 minutes on a problem and still didn't come to resolution. That's always a frustrating place to be.
Yes, it was kind of frustrating, but I figured you would have a math lab, so I just kind of left it.
Yeah.
Same thing kind of happened yesterday. I got a couple of them done. I don't know if I was anywhere along the correct lines, but we'll have to see.
I'm sure you were. Okay. If this is okay with you, just because I said I really like to show it in Desmos, it looks to me you were supposed to start with number 3. Is that correct?
Yes, ma'am.
All right. If you kind of had to guess at number 3, and you were also supposed to graph the parent function, yes?
Mm-hmm.
Okay, so can you see that?
Yes, ma'am.
Okay. You were supposed to do that first, where our asymptotes are going to be the x equals 0 and y equals 0. Because that's our parent graph. If you had to guess, and just remember, no big deal if you don't get this right, but based on what the textbook says over here, graph the function y equals 3 over x and then compare it with the graph, because this is the example problem that kind of goes along with it. And they actually, on this particular one, they actually did they didn't show it vertically, but they actually they plotted some points just based on the information.
Mm-hmm.
They put in a -3, and what happens when you put in a -3 there? You would get a -2. And so they actually graphed points.
Do you do that in order to get the correct answer?
I mean, yeah. I mean, you definitely can do that, and that was probably the easiest thing. And I want to show you something on the example that's there. If you'll notice, they almost mirror, and that's kind of the point behind that. See how they kind of mirror each other. You got -3, -2, and then down, you'll see 3 and 2. Does that make sense?
Yes.
Okay. And then you'll see -2, -3, and that's 2 and 3. And that's going to be true because the parent graph in an inverse function is what's called a hyperbola.
Mm-hmm.
And so that's going to be true. They are going to mirror one another on the simple rational functions. So I want you to kind of encapsulate that in your mind, that it's going to, be on only on the simple ones. The harder ones, it's going to be a little bit different, but we'll address that ball when we get there. Okay. But so the graph of y equals 6 over x lies farther from the axes than the graph of y equals 1 over x. And that's probably going to happen on that problem y equals 3 over x. And if you stuck in a couple points on this one, let's just say we stuck in a 1 for x, what would the y be?
Just 3.
Yes, ma'am. That's it. Perfect. So if you stuck in a let's make something even there. If you stuck in a 6, what would you get?
1/2, right?
Yes, that's right. And so what you could do if you graphed that, because we know it's a hyperbola, you've got 2 points there, and I can promise you they would be mirrored on the other side. Does that make sense?
Yes.
So you would be able to draw that, but just to show you what that looks like, we've got y equals 3 divided by x. And what happens? It goes just a little bit further away.
Okay, I see.
Technically, it should be by 3, and you'll see that better in that next lesson.
Okay. So for the homework so far, does it have to be like very accurate?
No.
Okay, good.
No. I'm fine. If you just get a couple of points, like draw that y equals 1 over x, and then get a couple of points to kind of help you get that second curve. And obviously that second curve is going to be just some distance away. Mm-hmm. And the caveat to let's just go ahead and graph number 4 and number 5 while we're here, because I feel, I don't know, I might be wrong about this, but I feel like being able to see this, for me anyway, to be able to visually see how the graphs differentiate. Like, to me, can you see this okay? Still? Can you see the green line? Yeah. Okay. See how it gets even, like it's a little fatter even. It's further away from that red parent graph, but it's even a little fatter. So when that number gets bigger at the top, that curve is less like hugged into the origin, if you will. Mm-hmm. But once again, if we put in a couple points in there, if you put in a 1, it would be 1 and 10. If you put in a 2, it would be 2 and 5. So, you can see those, like here's 2 and 5. I'm not able to really draw on this very well. Let me see if I can see right there. Is it showing up?
Yes, it is.
So, those points are there. And so if I were you, when I get to a problem like that, I know the rough sketch that it's going to be. It's going to be a hyperbola. I have an idea of what that 1 over x looks like. And if I get 2 points, that's, for me, that's good enough.
Okay.
Just give me a couple points, and also remember, because it's a hyperbola, on this more simple rational function, it's going to mirror.
Okay.
All right. And then that key for number 5, what do you think, given the fact that it's a negative, what do you think is going to happen? Remember, no wrong answers. It's just you and I. We're learning together.
I'm assuming it's going to be flipped the other way. So like in the different corners of the graph, maybe?
You are right. You are on fire, girl. That is absolutely correct. Look at that.
Well, that worked.
Huh?
I guess that worked. I have no idea.
Yeah, you did great.
Okay, good.
You're doing perfect.
Good. Mm-hmm.
So right now, and if you want to, and I have no objection to this, if it helps you, like one of the young ladies that I tutored in college algebra, she used colored pens and that really helped her. So if you wanted to do colored pens and actually, or colored pencils even, so it's more erasable, so that you could actually see the graphs as they change and say, okay, this is the parent graph and it's this color. And you wanted to use the same graph for, say, 3 or 4 problems like this one, like 3, 4, and 5. I'm fine with that.
Oh, okay.
If that really, the most important thing for me is that you get the concept, that you understand it. So whatever is going to clarify it in your mind, I'm perfectly happy with.
Okay, sounds good. I already use different colors.
Yeah. So. I was going to say a lot of people do for note taking. I wasn't smart enough to pick up on that when I was in school, but I now, if I were to go back, I totally would.
It just helps me focus because when it's all pencil, it kind of blends together and I get bored very quickly.
Amen, sister. I'm totally with you on that.
Yes.
So.
Okay.
Now, what was the next number? Let's move. I think let's look at the next example, and that will help us with the next few problems. Okay. Now, remember good old A, H, and K?
Wait, can you give me 1 quick second?
Yes.
I just have to quickly do number 5.
Oh, I'm sorry. Do you want me to go back to Desmos?
That would be great. Thank you.
No problem.
I never know what numbers to plug in, like to get.
If I were doing this one,
yes,
just because I want to make my life easier, I would probably use 1, which would give me 1 and -5. And then I would use 10, which would give me 10 and -1/2. And what I would also know about that is I would have, it would mirror over on the other side. So if I plugged in -1, I would have -1 and 5. I think I said that right. If I didn't say negative on that first one, I meant to. Like if I plugged in 1, it would be 1 and -5.
Okay.
If I plugged in 10, it would be 10 and -1/2. So I would be, that would be on this side over here.
Okay.
Like if I put, I'm trying to, it doesn't show 10 on the graph, so I can't really get to that one, but let's see, 1, where would 1 be? 1 would be over here. And he's going to be right there. Oops. And this won't go away. I'm trying to move that so that you can see. That should, it should give me a line. That should give me that 1 and -5. And then over here, the -1, that's going to be -1 and +5. Does that make sense?
Yes. Your mouse isn't moving at all on the screen, so I just kind of had to like mentally follow.
I know. I was trying to get it to move. It's a laser pointer, and sometimes it wants to work for me, and sometimes it just literally has a mind of its own.
That's fine.
That's why I was trying to make it highlight there,
it's okay,
but I can't get it on there exactly. But anyway, the basis of my point is once you plug in the positive 1, you can plug in the -1 and know that it's going to give you that, it's going to mirror over onto the other quadrant.
Okay.
They are perfect mirrors of one another.
Okay, that makes sense.
Not until we get to like 11, 12, and 13 are they going to not be mirrors, but we'll get to that in a minute.
Okay.
That's where we're going to go back to that friendly A, H, and K. Everybody's favorite.
Yay.
Yes.
Okay. So now we're on number 11, right?
Yes, ma'am.
Okay. Sounds good.
Okay. And so what we're going to do is kind of take a look at this page before we move into number 11.
Okay.
To kind of go over how we'll approach those problems.
That sounds
the translations, we'll apply the translations of the simple rational, the parent function, the y over x, very much similar to what we did before Christmas. The h, which is in the denominator in the graphing translations, that form y equals a over x minus h. Remember, that was the one where the x minus h, it's the opposite of what we think. So like, although it's minus, you're going to move right. And when it's plus, you're going to move left. Do you remember that vaguely?
yes.
Okay. But when it's the k, when it's a plus k, you actually do move up. And if it's a minus k, you move down. But that's going to adjust. The k is always associated with the y, and the h is always associated with the x. And your a is going to be that stretching.
Okay.
Kind of like that was what was happening with with the simple rational functions, is you could kind of see that they were getting fatter and further away from the axes.
Right. Okay.
Okay, so that's going to be kind of the key thing to remember, to keep in mind, both for this lesson and the 5.3, is watching your vertical and your horizontal asymptotes. The vertical asymptote is going, sorry.
It's fine.
Excuse me, is going to be your denominator. So that's going to be like this 8x equals h and y equals k. Those are your two asymptotes, but your vertical one is the x equals h. So where the vertical one would be is anywhere where that would be equal to 0, because remember, the asymptote is kind of that place that the line can never touch. So thereby it's undefined. And so that's why you can't have a 0 in the denominator. So that's what the vertical asymptote is going to be.
Mm-hmm.
And so where that's going to happen on this particular one, and the horizontal asymptote is going to be your k. So that's going to be where it goes up or down. And so that's because it's shifting away from the origin. Remember, on the simple one, basically the x-axis and the y-axis are your horizontal and your vertical asymptotes. So whatever the adjustment h, that's going to move your vertical asymptote, and whatever adjustment the k, that's going to move your horizontal asymptote, either up or down.
Okay.
And that's just a general speaking. And as we apply it, I think that will become clear, but I just thought it would be better to go over it. Now, in the example, we've got x plus 2. So automatically we're thinking in our head, oh, plus 2 would mean to go right. But since our formula is minus, then that literally means that my vertical asymptote is going to go left. I'm going to move 2 places to the left. So in this particular case, my vertical asymptote becomes x equals -2. Does that make sense?
Yes.
Because it's the opposite of what you think. But the k in this instance is -1, so it actually moves down 1.
Okay.
So my horizontal asymptote is going to be y equals -1. And typically, they don't here, but typically I think you would see most people when teaching and that kind of thing, when I draw asymptotes in class, they're going to be dotted lines.
Okay.
Mine are typically going to be very crooked dotted lines.
That's relatable. I understand.
So, so then basically what they've done is they've looked for a few points to plot by just sticking in some um, uh, points. And if you can look at the little note at the side, it's kind of a blessing, believe it or not, where it says interpret transformations. It
Mm-hmm.
says the graph of y equals -4 over x plus 2 minus 1 is literally the graph of y equals -4 over x translated left 2 units and down 1 unit.
Oh, okay, I see.
Okay. So
Mm-hmm.
that's kind of it. So they basically all it's done is kind of move everything a little bit.
Okay.
All right.
Yes.
All right. So let's move on to number 11. All right. And I'm going to leave the parent graph up just because I think it's kind of fun to watch it translate. All right. And number 11 says y equals 4 over x. So we're really not doing anything to the x. So the asymptote for that particular one is going to stay the same. Does that make sense to you? It's still going to be x equals 0.
Okay.
So it's not changing at all.
Okay.
However, we are going to translate up 3 units. So my asymptote, I don't think it'll let me draw on here, which makes me kind of sad.
That would be helpful.
I know it really, really would. For this case, I've got y equals 3 is going to be my asymptote. I know it really would. I don't know what this does. What does it do? Nothing.
Maybe on the little
On
setting.
that setting thing?
Mhm.
No. Oop, no, it just lets me copy. Huh.
That's disappointing.
I know. I know. I wonder.
Maybe the three bars next to untitled graph.
No, here, let me Google it over here and say, can I write on Desmos? Can I write on Desmos while teaching? Nope. I can't see anything right off the top of my head, unfortunately.
I'm looking it up over here too, so.
Okay. Tell me, I had somebody figure out how to make straight lines on my Cami blank graphs today, which was wonderful.
Hmm.
Um, but why?
I found the Desmos user guide,
Uh-huh.
but there's nothing on here about writing.
Yeah.
I guess you can't.
Oh, you know what I'm gonna do? I know what I'm gonna do. I'm gonna see y equals 3. That is where but I'm gonna see if I can make it dotted for you. There surely has to be a way that I can make it dotted. See the black line that I just added? If that were dotted, that is and you can kind of see how the purple line comes near it.
Mm-hmm.
And x equals 0, x equals 0 remains my horizontal asymptote. So that purple line is gonna go near it, but never touch it.
Oh, I see.
Okay, and I'm actually gonna take away my parent graph just to make that a little clearer.
Okay.
Okay, see?
Yes, ma'am.
So it would get near it, but never touch it.
Okay, I'm just writing that down. There
Okay,
we go,
no
got
problem. No problem. It's just and like I say, I'm not looking for perfection. What I will look for on this more than anything is if you give me a dotted line that shows me you know where your asymptotes are and you've got a couple points plotted.
it. Okay.
That's what I'm going to be looking for. I am not going to be looking for perfection because that means that I would be drawing perfect graphs, and that's just not even going to happen. And I am going to try and figure out how I can make some dotted lines on Desmos.
It also says for us to state the domain and range.
Okay, let's talk about that.
Okay.
That's a very good question. On the domain and range on this. If you think about it, what the domain could be any number except for what?
0, right?
Yes, ma'am. That's it. Exactly. And the range technically could be any number except for what?
3.
That's it.
Oh, I see. It took a second, but I got it now.
Yeah. Yeah. You're doing great. You're doing awesome.
Okay. Got it. I keep forgetting to do like specific points. So,
Yeah, well, that's really okay. That's something you could go back and fill in. It's not, and like I say, on this particular one, I would do something easy. Once again, I would do 1, which is going to give me 4 plus 3 is 7, so 1 and 7.
mhm.
And then I would do 2, which is going to give me 2 plus 3, which is 5, so 2 and 5. And then once again, this we haven't really gotten into the real complicated ones, so this is still going to be a hyperbola, so it's going to be mirrored over on the other side of our 2 asymptotes. Because instead of it being the x and y axis now, our asymptotes have adjusted. Well, at least one of our asymptotes in this particular one is adjusted. So that will be where your hyperbola will now be mirrored. Does that make sense?
Yes.
Okay. So once you get 2 of them, in these simpler ones, you're like, oh, okay, it's going to be mirrored on the other side. Unfortunately, 5.3, it's not quite as pretty.
Dang it.
I know. I know. But
Okay,
once again, I'm not going to prohibit you from using your graphing calculator. So,
great. I haven't done today's math yet, so just
oh,
we probably won't get to cover that in math lab.
yeah. And I was going to say, with regard to that, it's not graphing.
Oh,
It is multiplying and dividing these rational expressions that you dealt with today.
oh, that isn't terrible.
No, it's not terrible. The as long as you don't mind factoring, it's not horrible at all.
Okay.
And I think for the most part on these, the factoring is fairly simple. Like where the leading coefficient is not like a 2 or a 3 unless you're gonna factor out a 2 or a 3. Does that make sense?
Mm-hmm.
So it's really not that bad. And I have a dentist appointment that I have to leave for in just a few minutes. So what I might do is when I come back later on this afternoon is just email you and say, hey, let's hook up in a Google Hangout again and we'll finish.
Yeah, that sounds fine.
Okay. And if not, obviously I'll have a math lab on Thursday and we're going to do a review assignment tomorrow and a review assignment on Friday, and I'll have math lab again. So maybe this is a good place for us to kind of like let this soak in,
Mm-hmm.
and then I'll come back and we'll do a couple more, but let's just go ahead. What's the next one on the list?
19. I was just going to ask really quickly if there's any way, if we can't do math lab today, since I have a study hall right after your period tomorrow,
Uh-huh.
I'm assuming we're going to talk about 5.3 tomorrow in class.
Yes.
Okay. Because I haven't finished that homework yet because I was also a little lost, but this is probably going to help. So,
Yeah, and that's fine. And here's my thing. For somebody like you who I know at least tried, you showed up for math lab. I'm fine with somebody not understanding and being honest and saying, "Hey, I don't get it." I mean, that's not that big of a deal. That's why I look for completion or at least attempt. You know what I mean? So,
That's good.
um, so 19 was the next one.
Yes, ma'am.
Um, okay, so if I'm looking at that one, I'm gonna if I'm looking at that one, what do you think the vertical asymptote is going to be?
-4.
Absolutely. Good job. And what do you think the horizontal asymptote is going to be?
+3.
That's it. Exactly. Perfect.
Okay.
So that's going to be something, and as a matter of fact, that's going to be something that I'm going to be looking for, and even you're going to see that even more in 5.3.
Mm-hmm.
Setting up those asymptotes is going to be key because that's going to help you. And so, what do you think then the domain and range would be?
Domain is all real numbers except for -4.
Correct.
And range is all real numbers except for +3.
That's it. Exactly. You nailed it.
Okay, good. I'm just gonna plug in some points and then I'll.
Yeah. And what I've done is I went ahead and drew the horizontal and vertical asymptotes for there. Mm-hmm. And if I were picking points, I would probably pick 0 mm-hmm. and 4.
Okay.
Let's see, 0 would make it -1 plus 3 would be -2. So 0 and -2. Or 0. Oh, and +2. Duh. Because -1 plus 3 is a +2. And there it is. It's on there.
Mm-hmm.
And let's see. If you picked 4, that's going to be -1/2 plus 3. So it's going to be 2.5. So it's going to be 4 and 2.5. Negative. Yeah, 4 and 2.5.
Okay.
Probably not the easiest thing to graph, but
it's okay.
But like I say, when I'm looking at these, I'm going to be looking, does this person know about the horizontal and vertical asymptotes? Because that is the biggest, I would say, obstacle or caveat to rational functions when you're rational equations when you're graphing them. It's just understanding those two things.
Okay. Well, thank you. I understand better.
Do you?
Yes.
Great. And plotting the points is a little tedious, and I'm not looking for perfection. So
okay, great.
As long as you understand the horizontal and vertical asymptotes and how they relate to domain and range and how important those are, we're good.
Okay, sounds good.
You've got 5.2 nailed.
Good.
And I will let you know when I get back, and we'll work on some 5.3.
Okay, sounds good. Thank you.
All right. Take care, sweetheart. Have a good afternoon.
You too. Bye.
Bye.